Once again, we are being asked to solve a system of equations by graphing. We're given that the system is made up of the equations y equals negative 3x minus 6 and 6x plus 2y equals negative 12. So our first equation is already in slope-intercept form, y equals mx plus b. So our slope is negative 3, or negative 3 over 1, or 3 over negative 1. And our y-intercept is at 0, negative 6. So we plot our y-intercept, 0, negative 6. And then our slope is negative 3. So down 3, 1, 2, 3, and over 1. Or, as I said, equivalent is 3 over negative 1. So we can go up 3 and left 1. Do that one more time. So we have 4 points to draw the line through. And then we have our line drawn through the points. Y equals negative 3x minus 6. So our second equation, we are given 6x plus 2y equals negative 12. Again, you can write this, or you can graph this in any way that you like. You can plot points. You can find the intercepts by plugging in x equals 0 and plugging in y equals 0 and solving for the other variable. Or you can do what I'm going to do as usual, and I'm going to solve for y to put it into slope-intercept form. So 2y, subtracting 6x from both sides, equals negative 6x minus 12. Divide both sides by 2. And we have y equals negative 3x minus 6. But wait a minute, that's the same equation we started with in the first place. So what this tells us is that these two equations represent the same line. If I plot these points, because it's going to be the same as it was in the beginning. The slope is negative 3 and the y-intercept is negative 6. So if I plot points, I'm going to end up with the same exact points. And I'm going to end up with the same exact line. So since I have the same exact line, what does that tell us about the solution to this system of equations? Since it represents the same line, there are infinitely many solutions. So if we plug in any x value into y equals negative 3x minus 6, we're going to get the same y value as if we plug that x value into our second equation, 6x plus 2y equals negative 12. They're two forms of the same equation. Different coefficients, algebraically manipulated to where variables are on one side or on both sides, but when we put them into slope-intercept form, we end up with the same exact equation. That tells us that these represent the same line, and therefore there are infinitely many solutions. Any point that falls on this line is going to be a solution to both equations.